Hi everyone, Professor Muhammad Shah with you. Our main subject today is about using thermal photovoltaics and photovoltaic without thermal beside the aid of horizontal axis wind turbine for electricity and water heating processes for domestic applications. First of all, open your MATLAB, okay? This is your MATLAB, and go to your destination folder from here, from this bus, okay? This is my hard drive, this is my working folder. So this is my working folder that I put my model here, so I can go here, okay? And this one, this is my working folder. Don't open your model from desktop, okay? And click here in order to organize by sort by name and group by type, so you'll find your files and data are stored here, and figures. Don't move any of these, okay? Any of this content, don't try to remove it or to delete it, okay? It may disturb your graphical interface of your system. So we have two options here in photovoltaic thermal, and horizontal wind turbine. Let's begin from the first one. Okay, double clicking. Okay, this one it's about utilizing or combining three different processes. Photovoltaic only for electrical power generation, and we have photovoltaic with electrical power generation beside water heating tubes inside, and we have horizontal axis wind turbine. Okay, you can set your simulation time into 0, okay? And this model is only a single point. It's about a single point solution. Okay, just a second. Okay, adjusting my position. Okay, this one is a single point solution, so you will get your result. Is going to be just one solution, one single solution. So if you double click here, okay, we need to set some our operating conditions here. This one is depending on your operating conditions. What is my solar radiation? Because this is basically the system is going to working or to be depending on, and we have what is your solar radiation limit and what is your average wind speed limit. Okay, so we have a controller inside, so this one is we should decide here. This is your solar radiation, so by removing this we can decide what is our solar radiation instantly, watt per meter square. Okay, and we have solar radiation limit. In this one I am going to adjust my system or to set up my system to work above this limit. If the solar radiation within the range of 400 watt per meter square, we are going to operate the photovoltaic system. If not, we are mainly depending on wind turbines or batteries. So if it's 400 or 500, suppose I would like to operate my system over for 500 watt per meter square. And solar radiation, I'm sorry, wind speed. What is your average wind speed? For my location, suppose its average wind speed it's about 5 or 8 meter per second. So, and my limitation is if the system is equal or above, for example, 4 meter per second, we should utilize wind speed or wind turbine system. If it is not, if there is no solar radiation, as you can see 300 and our limit is 500. So and if it is not, or if there is no existence of wind energy, so we are going to use battery. Okay, let's go for, suppose I set my limits for 700 watt per meter square, middle of the day. Okay, let's go inside here. We can serve our menu from here. Okay, this is our click here. Okay, so we have here wind turbine system, photovoltaic system, photovoltaic for electricity and water heating, and battery. You can adjust some input parameters. Let's double clicking on each one. For wind turbine, because this is a performance model, so we already have as a design specifications. What is your air pressure, wind speed? I disable this one because we have to control it from outside main block. And what is your site elevation? Okay, it's up to your design. Wind turbine specification. For maximum performance, I do prefer 30% or based on your module. What is your rotor diameter? Suppose I have a rotor diameter for lower specification. Okay, suppose I have 10 meters diameter. Number of wind turbines, suppose I have 5 wind turbines. Mechanical efficiency should be assigned. Rotational loss for the generator, rotational loss should be assigned. Power lag factor should be assigned. Your voltage, what is your voltage? That should be developed by your module. Okay. And this one is battery bank for the horizontal wind turbine, if you would like to depend on, okay, for system storage. Okay, and hit apply. Okay, let's go for photovoltaic system. We have here, we should assign also I disabled solar radiation from here because it is from the mother block. Temperature of the photocell. Okay, and we have open circuit voltage. What is your open circuit voltage? Short circuit coefficient, electron discharge or charge, band gap. What is your type? Is it polycrystalline, monocrystalline? You can select this for ideality factor. This is your ideality factor type. And packing factor, fill factor, resistance. So resistance, it should be as I think 1.5 as I think. Okay, number of cells, number in series, cells in parallel, almost 1. Number of modules, if you are going to produce larger power capacity, let it be 500 modules, for example. This is your cell area in meter square. Okay. The same for photovoltaic performance. However, we have to assign our input mass flow rate and water temperature L to the system. So wind speed for losses. This one is for the glass cover, because we are going to calculate the glass cover losses. L to water temperature to the system, normal. We are going to preheat this water flow rate. Mass flow rate, it depends on the area of your system. For larger area, you have to increase this one. Larger area needs a larger mass flow rate. You have to adjust this carefully. And we have here open circuit voltage. The same for ideality factor, resistance 1.5, I think. And ideality factor, backing factor, number of cells, and if is it a PCM storage, this one, there is some kind of paraffin wax or some kind of this. You can change your type by using thermal conductivity of your paraffin or. But I do prefer not the use of PCM in order to increase the outlet temperature, larger outlet temperature, PCM thickness, and some performance parameters such as emissivity of the plate, because there is a plate inside, emissivity of the glass cover, and absorptivity of the glass cover. This should be okay. This is our system. Okay. You can serve inside this. This is your output for wind turbine, average wind speed as the blades, axial forces, torque, bar coefficient, mechanical power, output generator power, and this is your net developed power, and this is total farm power, because we have many modules, okay, generator current, torque, battery ampere hour. In case of using battery inside the wind turbine modules, and you can access your code from here. Just double clicking on your block and you can access your code. What is your photon current, module current saturation, maximum power output, total power based on total area of your module. The same for thermal, but this one is little bit complicated, because we have to calculate glass cover temperature, blade temperature, mean blade temperature, outlet water temperature, and so on. Okay, battery. For battery, I think we need to, what is your output power from the battery, battery storage, battery ampere hour, battery load. Okay, that's it run at that single point. In this one, we need to utilize maximum power output. It's up to you. You can create your control. This yellow bar is your controller. You can put your own conditions. You can consider your own conditions in this one. It's up to you. For this one, I have choose that I would like to extract the maximum output from all of these parameters, or from all of these units. So I select max from here, from model browser. Okay, going to, I think, in mass operation. I can't, yes, minimum and maximum. Okay, so this one will adjust my output. I choose to utilize maximum power and to differentiate between these 4 units. Okay, let's saving our model and hit run. Okay, based on my operating conditions. Okay, and we have to see. Okay, so this is my output power. Okay, let's go inside horizontal wind turbine. Nothing, because my option is to utilize only photovoltaic or solar systems. This is my, so you can increase here, this power gauge. You can increase this by double clicking on the gauge, and you can increase the maximum gauge limit or range. Okay, you can increase this one, total power. Okay, let it be 250, for example. I'm sorry. Okay, saving. You can obtain this gauge from here. You can dashboard. Okay, and you can drag and drop a quarter gauge if you would like. Okay, so for this one, okay, outlet temperature. Okay, outlet temperature is raised from 25 degrees Celsius up to 61. That's so good. Okay, so as you can see here, this is output power. It's output power from the thermal photovoltaic is much less than the only photovoltaic, because some part of this power is going to be transferred to the water side. So the energy balance, you have to check your energy balance. So there is no output power from here. Okay, almost dead. Suppose I would like to use horizontal wind turbine. Suppose there is no solar radiation, okay, beyond this one. So let's check our wind turbine. Let's check our wind turbine. Okay, this is our output. Okay, it's about 27 kilowatt of power. You can increase this by controlling your specifications. Suppose I have, you may increase your diameter or number of units. Let's check here. The power developed. This is total farm power is 27. Let's hit and see. Okay, massively increased because we increased the number of units, so it is expected to raise up. So suppose I don't have wind. Okay, the wind speed is lower than my expectations, so battery should serve our system. Let's hit run and see. This is manually controlled, so suppose I would like to guess battery power is about 50 kilowatt of power. Okay, suppose I would like to change this and move toward this automatic controller, or I would like to change my specifications automatically based on the variation of operating conditions, such as changing on uncertainty in solar radiation and uncertainty in wind speed. So therefore I have to close this one, and you can find your result output here. How can I get my output here? You can, by two solutions, you can go to the sinks and try to use save your mat or workspace, this one. But if you drag this one here, suppose I would like to inspect my load power, connect here, double clicking, and change it to load power, one word, and it is array. Use array and hit apply and saving, and if you hit run your model, you will find this one with the same name saved to workspace here. Load power, yes, this one. Yes, you can drag and drop, and you can save this in Excel sheet if you would like. Suppose I would like to not use this block, you can go in here, model browser, this one. Okay, model explorer, and click here, one click, and going here, and for example wind turbine. These are your input and output parameters. Just select whatever you would like. Okay, for example, and click description and save final value to workspace and hit apply here. You will find your results storage. For example, this is M-air. Okay, mass flow rate of your, yes, this one. This is mass flow rate of your because there is no result for wind at this example. So okay, let's go automatically a little bit. Okay, I have another option, second version. Let's double clicking here. Let's close this saving. Okay, never mind. Okay, this one I created a signal, so I would like to change my expectations or my outputs. This one should be run in dynamic mode a little bit. It is not dynamic mode, but you can consider it a real-time simulation. So there is no need for this. Okay, there is no need for this. Okay, because I will control the system by an output signal. So I close this. This is your solar radiation input. So I uncomment it. If you click here, you will uncomment. Click here to commit. There is no effect from the mother block. If I try to change this, there is no effect. So it is better for you to right click here, going to the mask, edit mask, and going to the parameters. Okay, solar radiation, and make it enable, no, disable, and average wind speed, disable this one also. Okay, there is no meaning. Okay, double clicking, as you can see here. Let's shrink it, maximize a little bit. Sorry. You realize there is no, you can control this. There's no, it is disabled. All of this, these two parameters are disabled. There's no, only your solar radiation limit. We need these two parameters. Okay, solar radiation and wind speed limits. This is my controller. The limits are going to tell us that your system is not working beyond these limits. Okay, first of all, let's saving. Suppose I would like to send my result to data inspector and to draw some figures. So all we have to do is I would like to inspect the output load from wind, the output load from photovoltaic, output load from PVT, and the battery and load power. Okay, so what I am going to do is to send my result to data inspector. All you have to do is to highlight all of these signals, okay, and going here and click to currently I will stop this, okay, but you have highlight this and click here, stream selected signals to data inspector. You will click and you will file a small visualized square. This one telling us that your signal or this signal is sent to data inspector for inspection. Okay, let's go for I did the same for all my signal I would like to draw or to examine. As you can see here, for photovoltaic, it's the same. I did the same for all. Okay, or you will find, you click here and you'll realize this is small square. If I click it, I removed it and click again, and data will send to inspection. Okay, so in this controller, I am combining all my results. There's no minimum or maximum. This is scope. You can find it here from the sync. This one scope. Okay, and right click here. I'm sorry, you can right click here and I think properties, no, not from here, just double clicking and right click here, and you can choose your style, your configuration parameters from here. It's up to you. Okay, and I set my simulation time to 24 hours. Okay, so my input signal, which are solar radiation and wind speed, should be in 24 hours. Let's go here and double clicking. I will create my signal, my own signal. So this is my own signal. I suppose that I have a shape like this for solar radiation. Okay, you can control this by yourself. You can increase or decrease. It's up to you. Okay, suppose I have this shape for wind speed. It's up to you. Okay. I create this by my own self. I just supposed that I have this data. So how can I create this? First of all, click axis, change time range. You should be the same as the simulation time of your model. It is from 1 to 24. From where? From here. Click here and let's go for yes, start time is 1, end time is 24. So in signal builder, where can I get this? I'm sorry, where can I get this? This one should be obtained from here, sources, not sync, sources, and I can create my own signal. This one, signal builder, you can drag and drop. You have many sources of signal you can depend on. It's up to you. But I do prefer to create my own signal by myself. So signal builder, okay. So I create this one. Okay, how can, after setting your time range, click on signal. Suppose I would like to create a new one. For example, create constant step. It's up to you. For example, constant. So it will give me another signal here. Okay, and I can hold shift and create on adding more points by myself, and I can create this by myself. Okay, for example, and I can name the signal from here. Okay, there's no need for this one. Okay, and let's delete this. Yes. Okay, so I have you can also arrange your signal index. What is your index? I would like to signal 1 should be solar radiation and signal 2 should be wind speed, and close this one here. Okay, so I connected this, so solar radiation, wind speed. Okay, and this is your operating conditions. So my input data, which are solar radiation and limits on wind speed and their limits, would be sent to each of these. And let's go, for example, in my horizontal wind turbine. Okay, based on my my conditions or my assumption, the limits, the system will run and compare your results. Let's double clicking and hit apply from here to see what is going on. As you can see here, at the beginning, okay, yes, for example, as you can see, I can't remember, this is the variation of your power. I can't remember the colors. I have to you can print your display figure. Okay, that's going for configurations and limits for I think this one, style. Yes, maybe in style. Okay, load in yellow. Yes, load 1, which is I think wind speed, okay, is in yellow, and we have here load 2 is in blue, which is I think photovoltaic. Yes, and the third one is I think is red, which is thermal photovoltaic, and the green is your battery. Okay, so as you can see here, at the beginning, based on my signal inputs, we have battery, and there is no battery at all, because the wind speed is has better existence. And then we have the solar radiation, as you can see here, start at maybe 9 and 9.5 o'clock. So solar photovoltaic and solar thermal photovoltaic both are responsible for the power and water heating production, with a slightly existence to the wind speed as the middle of the day. And then we have, there is no sufficient power from the wind and from the solar, so the battery is in work, and then there is no as the wind speed will continue the power supply to the end of your day. Okay, suppose I would like to change this along 1 year, for example. Okay, how can I extract my result? Click here on this one. Firstly, let's go here for going to 1 day. Okay, you will find your result here. Okay, I will click here, for example, and delete all. I will delete all and start over again. Okay, that's saving with a new run. Okay, that's it. Okay, as you can see here, system is running. Okay, let's close this one. Okay, how can I extract this? You can send this to a figure if you'd like, or from here, data inspector. Let's go for data inspector. These are your outputs that you already highlighted. Signal, for example, horizontal wind turbine load. That's the load on your horizontal wind turbine. The signal input. Okay, suppose I would like to add more slots. You can add more slots from here. Okay, horizontal wind turbine. You can let's go for photovoltaic wind turbine. You can search from here for load on thermal photovoltaic. and I would like to inspect load on photovoltaic. Yeah, photovoltaic power. I think this one. Yes, this one. Okay, the same result. You can inspect, for example, outlet water temperature variation. The water outlet. Okay. This is PV thermal photon current, PV thermal total power. Okay, PV thermal power, fluctuating, useful energy, and for example, battery power. Okay, current of a generator current. Okay, torque, and battery ampere hour, number of batteries, spacing. Okay, axial force on wind turbine, torque in Newton meters, power coefficient. I think it's constant. Yes, wind power, mechanical power. Okay. So, and you can send this to a figure. You click send to a figure here. Okay, and click here, click plot tools, and I can change my, let's see, to a jet, white background. Okay, so hold shift and click on all of these, and we need this is my time by hour. Okay, and you can change your figure based on your font. What is your font style? Times in New Roman. Okay, so you can change your time, your lines. For example, let it be thickness of your line. Okay, it's up to you. You can change the legend from here. You can do whatever you would like. What is this one? You can drag and drop here, I think. Here, I think. Okay, or IPV. Okay, anyway, so you can use MATLAB tools in order to extract your output result based on your inputs. Okay, suppose I have another idea. Let's delete all. Okay, I have another idea. The second idea is to use this one, sources and sinks. Sync and send to workspace. Okay, suppose I would like to change some input parameters. Let's go from here. I would like to inspect the number of battery. Okay, number of battery. What I'm going to do with this one. Okay, this one is just an example. Okay, or diameter, rotor diameter. I would like to inspect one. Firstly, you can use this one. You can copy this one here alone, and another model, and put it here, and you can use operating conditions as well. You can use this one, copy it and put it here. So we can inspect only horizontal wind turbine without any need of your solar radiation. Okay, you can inspect your let's click here and show some okay, let's go inside. Suppose I would like to inspect my number of wind turbine effect on my system. Let's do this. Set your simulation time into 24, from 1 up to 24. Click here at apply, click OK, and let's see if I have something like this. for example. Okay, but this one needs sync display, and this one, okay. And we can write here, double click on the signal and write horizontal wind turbine power load in kilowatt. Don't add semicolon or colon. Okay, and highlight and send to data inspector, and double clicking on this gauge and highlight your signal and click here and set your limits. Suppose it's a 500, hit apply and choose bottom, and okay. I would like to change my this one. I would like to change this one. What I can do here, you have to click on the signal, or you can do this sources. Okay, signal builder. Okay, and remove this one, Control X and Control V here, commentate and create your signal. Suppose you have a number of axes from the same axis, it's from 1 to 24. Okay, and I would like to change my number of wind turbine units. For example, I have this. I would like to see the effect on my power. Okay, just random numbers. Okay, I would like to see, and close this one. Let's check again. Okay, and let's hit run and see. Okay, I have to use this outside this. Okay, Control X and put it here, and I would like to use another input, going to the source input here, this number 2. Okay, and going out here. Okay, if you right click here, edit mask and opaque with ports. Okay, hit apply in order to recognize which input you are going to attach with. Okay, let's move here, and I'm trying. I think it should be saved as any. Okay, I'm trying. Let's try this one. I think wind speed limit. Yes. This one. Okay. This one should be assigned in. Okay. I think wind speed here. Yes, average wind speed. I think. This one should be removed. Okay. And solar radiation. There is no need for this one. I'm sorry. Solar radiation limit should be removed, and average wind speed limit should be removed. And hit apply. Okay. These two is not existed here. I think it should be work. Yes. So this is your effect on your the effect on number of units. It's just an example. Let's see the power. The power is fluctuating, and based on your wind speed beside the existence of number of units. Okay, let's close this one, and I would like to use this anymore. Okay, let's delete it. Okay, delete this one. Okay, let's return back. Suppose I would like to change this along 1 year, for example. Suppose so you have many options. The first option is to set this value along 1 year. Hourly, daily, monthly, it's up to you. If it's at months, you have to set your solution time into 12 months and give an average value per month. Okay, it is not 24, it is going to be from 1 up to 12. Suppose I have to do this hourly, so it is hard for me to create a signal such as like this. So all you have to do is to I have created this one, operating this Excel sheet, okay, double clicking, okay, and put this sheet inside your model folder. Okay, this is my model folder, okay, and here you are, this is your Excel sheet, operating conditions data. Click here, okay. So if you drop it here, let's see, it will open here, and yes, okay, you will find the following: 1 year results. This is 1 year results, 1 year, okay, winter and summer, okay, and this is 1 day in winter, for example, and this is 1 day in summer, okay. Let's see if I'm trying to connect this. I'm trying. Let's close this one. So I created this before. I already prepared it before. Okay, this is 1 year results, almost. Okay, as you can see here. Okay, so this is my time. You have to consider 3 columns: your time, solar radiation, and wind speed. For winter, this is 24 hours. Time, solar radiation, global horizontal radiance, and wind speed. Just an example. I would like to see the effect of this on my system. Let's saving and close this one. How can I use this? Let's try, and I'm thinking, let's save this one. Let's save this one. Save as. Suppose it's version 3. Okay, version 3. Okay, and save. And I would like to remove signal builder. There's no signal builder. Okay, I would like to use another thing. It should be from spreadsheet. This one. Okay, drag and drop here. And I would like to double clicking. You have to consider the same name of your file. Let's consider the same name. I will copy it. Control C. Okay, and put it here. I'm sorry, put it here. Yes, I will name it as operating conditions. Okay, double clicking, and I will put it here, Control V, okay, and hit apply. What is your sheet number 1? I think sheet number 1, I can't remember, I have to double click in here. Let's see here. Okay, sheet number 1 is 1 year, sheet number 2 is winter, sheet number 3 is summer. Let's go for 1 day, for example. Let's go for 1 day, summertime, and I would like to see 1 year. Let's go for 1 year and see. I think it's okay. Yes, I will double click and copy this, and let's go here. Okay, this is my sheet number 1. I will copy this one. Okay, it will make your automatically will interpolation, extrapolation, and do everything. And hit apply. Okay, because it's a huge file. Okay, so now we have here solar radiation and wind speed. Impressive. Let's control this, Control X, and put it here, Control V, and close this one. I will attach my inputs. Let's attach this one. Okay, so I connected. What is your timing limitations? Let's go here and make it variable step. My time is from 1 year is 8,700 68 of hours. And maximum step size, let it be 10 because it will take much time, as I think. So okay, if we have here, I think it may take a lot of time. Let's see, I'm trying. What is your solar radiation limit? I think solar radiation limit, let it be, let's begin from 300, and wind speed should be start at 2, maybe 2 is 2 meters per second or 3 meters per second. Okay, just an example. And saving, I'll try. I have nothing to lose. Let's run and see. It may take a lot of time. Okay, your x-axis is your year. Oh, okay. As you can see here, the green one is battery's time along the year. The yellow one is your wind turbine, and almost the whole year is operated by photovoltaic, and the red one is your photovoltaic thermal, as you can see here. Very good. Okay, suppose I would like to run a summer day. Summer, you have to type it the same as the name of your sheet. Click apply, and this is one day in summer, as I think. Yes, summer. Okay, it's just an example. Okay, no sun rays. Okay, and end of the day. Okay, let's go inside and see if I can. Double clicking here and hit run, saving. Let's see if I can do it. But I think step time, step time should be lower than this. Yes, I forget to adjust my step time. Make it auto again because it's limited. I'm sorry. This is 24 hours. I forget everything. Yes, this one day. So it is 24 hours, one day, and let it be run. Okay. Let's see. One day. I think this is. There is almost no battery because we have plenty of wind speed and solar radiation, and this is a variation of your thermal photovoltaic. You can extract your output temperature. Also, you can extract this one, outlet temperature. Maybe you can dashboard here, and you can drag and drop this one, and double clicking, and my let it be 100 degrees Celsius. Select this one, outlet hot water temperature, T water out, bottom. Okay, hit apply and see. Let it be. I'm trying to use this dashboard scope also. If it work, it will be nice. Double clicking, T water out, TW. Oh, it is not working with this one. Okay, no problem. No problema. Okay, saving. Hit apply. It will fluctuate along the day, up and down, little bit. Okay. You can draw it from the data inspector if you like. From here, T water out was, this is plate temperature. Yes, glass temperature, and water out. Yes, the red one is little bit lower, of course, than the plate temperature, as you can see here. Okay, and this is our main output result. Suppose I would like to change the limitations. I would like to increase the limits of your the operation of wind. So try to reduce your wind speed, reduce it, the range of all your conditions. Suppose I would like winter. Let's try to compare winter. Okay, I think this one. Hit apply. Okay, and see saving. I think this one battery will have the chance. I think battery should be involved because of, yes, battery time, because we are in winter. So as you can see here, battery little bit. You can change the range if you'd like. You can fit to scale. Okay, as you can see here, battery time at the beginning of the day, midnight, early morning, solar, and returning back to wind speed. Take its a chance here and return it back again, and you can find your output here. Okay, this one. Okay. Finally, I would like to thank you very much for your interest in our model. Don't forget to like, share, and subscribe. I forget to tell you that you can change your you can use these sources. You can use these sources to inspect for example signals, especially signal builder, in order to get your fluctuating results and simulate the real-time simulation of your model practically to your real one. Finally, thank you very much for your interest. Don't forget to like, share, and subscribe. Thank you very much.